Okay. Here the given problem is, let me start the timer. Okay. Here the given problem is rotate an array by 1. Given an array, rotate the array by 1 position in clockwise direction. Here what they are trying to say is they will given one, if they give any one array, we need to rotate it by 1 position at clockwise direction. So this means right rotation. Okay. Here we say 1, 2, 3, 4, 5, and the output will be like 1 rotation. Which means the 5 goes to the initial part and the remaining stays the same. Just move 1 position right side. Here they explicitly given as 1 position. But in most other common problems, they won't give or say explicitly 1 or 2. They will pass the value dynamically like any k or n elements. Okay. To solve these type of rotation problems, we go for one approach, like it's be like AKR. It's AKR is just a simple word we can say as it's AKR. A. What A means? Sorry. Reverse all the elements. K means reverse the K, reverse the elements, reverse the K elements. K means nothing. Here K is here K is 1 because they explicitly give 1 position, and R means reverse the rest elements. That's all. This is the AKR approach. If they said, if they are asked us to reverse the rotate the array left position, left side means we go for the KARA. These three reverse tricks. Okay. Here we are going to solve this by AKR. Okay. It just mean nothing but a right rotation or clockwise. This is for left rotation or anti-clockwise. Okay. Now we will solve the problem. First, we will take the length of the array. Length is length of an array, which this thing is needed for us, and we take the modulus of the k elements. Here we take k equal to 1. Okay, because they explicitly given us 1 position, then k equal to k mod n. Why this thing is needed? Let's say if they given an array of 3 elements and they want the array to be rotated 3 times, which means the after the 3 rotations the end result will be same as like the initial value. That's why we are going for this approach. Suppose think like they given an array 1 2 3 and they want to rotate it by 3, then the first rotation will be like 3 1 2. Second rotation will be like 2 3 1 2 3 1. Then the final rotation will be like 1 2 3. It is same as the initial given array. So this is why we go for this modulus part. Suppose like the given is k is 3, 3 mod 3 is equal to 0. So we don't need to waste our time computing power on rotating this thing unless if not needed. Okay. For our to implement our AKR technique, we will create one helper function reverse. Okay. Uh, diff reverse. Okay, what this function do will it take one array. Okay, it takes one array A and two values left right? Okay, it just first we need to implement the three parts first. Okay, while it just need to swap the elements. That's all the reverse part will going to do. This helper function. Okay, reverse AKR just for this common thing. Okay, while left should less than right, right. Okay, it needs to like a of left, comma a of right is equal to a of right, comma a of left. Actually, what we are doing here is we're just swapping the values. That's all. No rocket science. Not like this stuff. We're just swapping the values. That's all. Yeah, we're just moving the left pointer plus one, left equal to left plus one, right. We decrementing the right pointer, right equal to uh, right minus one. That's all. Our helper function value is done. Okay. Then we call our the final AKR. Okay, reverse AKR of what the array we are going to process ARR, and the left first the AKR rule is reverse all elements. Reverse all A. It's the A part. Reverse all elements. The left will be our starting value, and right will be our last value. This is nothing but n minus one. Okay, this is the A part. Second one is reverse AKR of again we pass our array. Here we are going to reverse the k elements only. It's nothing but our the starting will be the zeroth element, and we reverse n minus k minus one elements. So k minus one. Okay. This is our AKR. Okay, kth part. How many elements we need to reverse is k elements. Here one. Okay. The final is reverse the remaining elements AKR of pass the array all elements k to n minus 1. That's all. Here what it will be do like final part. Okay, it will be like it will return us our the first it will reverse all the elements. It will be like 5 4 3 2 1. This is our first one first result. Then it will reverse only the k elements. K is at 1k 1 minus 1. If we pass the k as 1, it will be go there. Left will be 1. 1 minus 1 will be 0. 0. Okay. Here it will be like we need to give us 0. Then the no repetition will be take place. 5, 4, 3, 2, 1. That's all. The final will be like we need to repeat the k elements, k rest elements. Okay, then will be like it will pass through this, and like 5 1 2 3 4. This is our output will looks like this. Then finally we need to return our array. Return array. Here what we done is in array modification we have done that. The A part, the final three tips are: first, we need to rotate the entire array. The second thing is we need to rotate the k elements only. The final one is we rotate the rest of the k elements. Okay. Compile and run. The array shows like you mean reverse AKR DVR is oh sorry typo. Our output has paused. Okay. Now the solution has paused. You can follow this approach, this AKR approach, to solve any problems. Whether it's a left rotation, right rotation, any problems, we can solve this solution. Okay. Uh, let's solve this same problem, but in a different one. Here they given an array. Let me zoom the screen. Okay. Here they given the problem is given an array with n elements. The task is to rotate to the left by k steps. Here what they needed is they want to rotate the array k times by left rotation. They want to left rotation. Okay. Here it will be like 2 3 4 5. The one goes the right side. Previously we have done the right rotation. Now we are going to do the left rotation. Same AKR method. We just copy the solution. Same AKR. Okay, no change. Okay, just to copy the solution and paste it. Okay, same AKR method. The small changes, instead of AKR we are going for the KRA. Just KRA. Cut it, cut this, paste this. That's all. Okay, run our solution. What wrong is 613611 desired output, your output. One, two, two, one. Okay. Okay. Here, why our solution got an error is here we hard coded this one. That's the problem. Just comment this one. Now run, passed. Submit our code, passed. That's all. Just remember this one AKR and KRA. That's all. Okay. Just a small, just write on one helper function and again call this three helper function three times. With the first one is reverse all. Second one is reverse just a k times from start to k. Then reverse the rest elements. That's all.